till now. SI unit assignment. The question one is, which of these units is same as Newton, like the base unit of the force? You can also use a chat to state the answer. I'll solve some of the questions and remaining you will solve as a homework. So we want to work out the unit of force, like force, unit of force is Newton, but the base unit. So we have the formula F is equals to m. As I mentioned, that whenever you want to find the base unit, you can write a formula for that physical quantity. Any formula, it won't make difference to the base unit. Then the SI unit of the mass is kilogram, so we write kg. And SI unit of acceleration is meter per second square. So when we represent them in a base unit, we represent all of them in numerator. Second square is there in denominator, it will move to numerator. So it turn into kilogram meter second raised to power minus 2. So kilogram meter second raised to power minus 2. It means option B will be the right answer. So whenever you need the base units, you always write a formula and then find out the base unit. In question 2, a football is kicked at a speed of 12 meters per second at an angle of 35 to the horizontal. The horizontal component of a velocity. So there's a football which is kicked at a speed of 12 meters per second. And it was making angle 35 with the horizontal. So this angle is 35 degrees. We want the horizontal component. So there are always two components. The one which is with an angle here in this case, that is a horizontal, and against angle is vertical. Now we need the horizontal component. To get the horizontal component, we will use the trigonometric ratios. So this will always form a right angle triangle. So for a right angle triangle, we have the hypotenuse, we have the perpendicular, and we have the base. So if I need the horizontal component, I need the base. So the three trigonometric ratios which we have sine theta, which is perpendicular divided by hypotenuse. We have cosine theta, which is base divided by hypotenuse. And we have tangent theta, which is perpendicular divided by the base. So what we need the horizontal component, and we have the hypotenuse. So which one include the horizontal component? Because the base is a horizontal component. So which trigonometric ratio I should use? I should use cosine theta. Why not tangent theta? Because if I use tangent theta, vertical and horizontal both are unknown. So two unknowns will be there. We want the horizontal component or the base to be unknown, and one of the components should be known. That's why we are using a cosine theta. So we have the formula cosine theta or cos theta is equals to base divided by hypotenuse, which is 12. And the theta is an angle. So what angle it is making? 35. So we'll put 35 here. So cos 35 is equals to base divided by 12, because cos theta is equals to base divided by hypotenuse. So cos 35 equals to base divided by 12. 12 is divided, other side will be multiplied. So when we multiply, the horizontal component will be 12 cos 35. That's why A will be the right answer. But what if they ask for a vertical component? If the same question was there, instead of horizontal, they ask for vertical. So when they ask for vertical, in that case, we will not use cosine theta, we will use sine theta. So we'll use a sine theta, and this sine theta will be equals to perpendicular, which we don't know, divided by the hypotenuse, which is 12. And what about the angle? The angle is given 35 in the question. So this angle is 35. So this 12 is divided, other side will be multiplied. So the perpendicular or the vertical component is equals to 12 sine 35. So if the same question was there, they asked for vertical component, then option B will be the right answer. But because they asked for horizontal component, that's why A is the valid answer. The next one is, which of the following is a scalar quantity? So when we work out the scalar quantity means which is having magnitude unit but no specific direction. So displacement is a vector quantity, force is a vector quantity, velocity is a vector, the only scalar quantity is time. That's why C will be the right answer. Which of the following is not SI base quantity? What are the SI base quantities? There are 7 quantities and the units are like kilogram. So what are the SI base quantities? Length, time, temperature, current, electric current, mass, amount of substance, and the light intensity. These are the 7 fundamental or the base quantities. So when we check the force, force does not belongs to this one. There is a length, there is a mass, there is time, but force does not belongs to this. So it means force is not the base quantity, force is the derived quantity. So any quantity other than these 7 are refers to derived quantity and their units are known as the derived units. Which table is correct for a scalar and a vector? So scalar has magnitude means value. That's true. Has direction? No. So option A can be an answer. When we check option B, the magnitude is there for both of them. So when you check option B, has magnitude like number? No. Like this is not the correct because they all have the magnitude. When you check option C, scalar is having a magnitude. Yes, but does not have a direction. That's true. Vector is having a magnitude and it's having a direction. So that's why C is the valid answer. Which of the following is a not unit of energy? So to work out this, which one of them is not unit of energy? You should write a formula like what are the formulas for energy? The unit of energies itself is joules. And what are the formulas for energy? Like work done is there first. Whenever work is done, that energy is stored or transferred. So work done, it is force into distance. Then another way, energy, because power is energy divided by time. So energy is power multiplied by time. And what is the unit of power? Like here, when you check option, the correct answer for this one, which is not unit of energy, is option A. But what about option B? Because it's kilowatt hour. Like power can be kilowatt and time can be in hour. So means that will make a unit for energy. Like that is a possible unit of energy. If energy is power multiplied by time, power might be in kilowatt and time is in hour. So the unit of energy will be kilowatt hour. So this is valid unit. Newton meter, if the force as the force is there in Newton and distance in meter, so the unit will be Newton meter. Watt into seconds, that's also correct because unit of power can be is watt. It can be watt, it can be kilowatts, but here if the unit of the power is watt and the unit of time is second, so it will be watt second. But Newton divided by second, like none of the formula gives Newton divided by second or ns minus 1. So there is no unit of energy which is ns minus 1. That's why A is the right answer. Like A is not the unit of energy. Rest all of them are the units of energy. In question 7, a body is acted on by vertical force of 18 Newton and horizontal force of 32. The angle to the horizontal of the resultant force. So there are two forces which are acting. A vertical force is 18 Newton and the horizontal force is 32 Newton. So as the two forces are perpendicular, to get the resultant, we'll use the magnitude of the resultant, we'll use a Pythagoras theorem. And to get the angle with the horizontal, like if I need this angle, it will make a right angle triangle. As a result, as it's making a right angle triangle, so we have hypotenuse, we have base, and we have perpendicular. So we have perpendicular and base. To get the angle, we'll use a trigonometric ratio, the tangent theta here, which is perpendicular divided by base. So tangent theta, which we want to find angle, perpendicular is 18 and the base is 32. If we need theta, that tan will move to other side, it will become tan inverse. So theta equals tan inverse 18 divided by 32. So 18 by 32 tan inverse, that's why B is the valid answer. So whenever you need the angle, you will use a trigonometric ratio according. Why specifically we use tangent theta, as we have the base and perpendicular. What if we were having a perpendicular and hypotenuse? Then we will use sine theta. If we were having a base and hypotenuse, that case we'll use cosine theta. The second part, we have to find the magnitude of the resultant. So to work out the magnitude of the resultant, we'll use the Pythagoras theorem. So same question, but we need the hypotenuse. So we'll use a Pythagoras theorem in which the hypotenuse square will be equals to the base square plus the perpendicular square. So base is 32, so it will be 32 square. The perpendicular is 18, so it will be 18 square and equals to hypotenuse square. If we need hypotenuse, we'll take a root, both side under root, so 32 square plus 16 square. So 18 square, not 16, 18. Because the perpendicular is 18. So it will be 32 square plus 18 square in a root. So option D will be the right answer. In question 9, which of the following is a vector quantity you have to identify? So distance is a scalar quantity, force is a vector, speed is a scalar, work is also scalar. So B is the right answer. Then which statement about the scalar and vector quantity is correct? Scalars have direction only, that's wrong. Scalars have distance only, that's also wrong. Vectors have magnitude and direction, this is the right statement. And vector have magnitude and distance, that does not make a sense. So vectors have magnitude as well as direction, but scalar have magnitude but no direction. Next is, which of the following is unit equivalent to Pascal? Pascal is a unit of pressure, like we want the base unit of pressure. So simple way, any formula you remember for pressure, like pressure is force divided by area, pressure is also density, gravity, depth. Any formula you remember, you can use, like example, if I use pressure is equals to density, gravity, and depth. So density is kilogram per meter cube times the gravity expression due to gravity meter per second square times the distance or depth is h height, which is in meter. When we simplify this meter, we'll cancel with two of them. So we are left with kilogram, meter, second square. Both will move in numerator, so it will turn out to be kilogram, meter raised to power -1 and second raised to power -2. So kilogram, meter minus 1, second minus 2. So option C will be the valid answer. What if another student used that pressure is force divided by area? So force is Newton or it is kilogram meter per second square, and the area is meter square. So when we simplify, this meter will go there in numerator, will get the same answer as kilogram m minus 1 and s minus 2. In question 12, a model boat is crossing a stream. The stream is traveling in east at a speed. So you have to take direction of the compass. North is always up. So north is always up, south is down, east is towards the right, and west is towards left. So a stream is traveling in east 1.5. So that is east is toward the right, which is 1.5 meter per second. And the boat is heading north at a speed of 0.5. So going north at a speed of 0.5. We want the magnitude of the resultant. The resultant will, whenever two vectors are perpendicular, the resultant is always the hypotenuse, like making a right angle triangle. So we'll use a Pythagoras theorem that hypotenuse square is equals to base square plus perpendicular square. So it will be 1.5 square plus 0.5 square, and then we take a root. So 1.5 square plus 0.5 square in a root. That's why D is the right answer. And the next part, we normally need the angle. So if they ask for angle with a horizontal, so what you will do? If you need this angle, angle with a horizontal. So how to work out the angle? We have the perpendicular and we have the base. So we'll use the trigonometric ratio that tangent theta is equals to perpendicular divided by base. So if we need the angle theta, that will be tan inverse 0.5 divided by 1.5. This will give us the angle. As it's not there in the question, they did not ask, but what if there was a question to get the angle, you will always use the trigonometric ratio. Depends on what quantities you have. Normally we have perpendicular and base, but what if you don't have, then you can use another trigonometric ratio. So these are some questions of assignment SI unit. That will be the first assignment I will share with you. So you will solve the remaining questions and submit next week.